Oh, Nick, come on. Here we go. Ready? Let's move on. At right is the graph of this function. Use the x-intercepts to write it in factored form. Boom. So A. They want you to write it in factored form. What is the general? That's a bad word to use, general. What is factored form? What does it look like in terms of like the A and the x minus root 1, x minus r2? D2? No. Okay, so here we go. We're going to go ahead up here, and we're going to look. Tell me what the roots are. Negative 2.4 and 0.8. All right, so those are root 1 and root 2. The order doesn't matter. I know you were concerned about the order, but it doesn't matter. You can have the negative 2.4 first or second. Order doesn't matter. What does matter is this. If I'm going to put negative 2.4 in as root 1, what's x minus 2.4? X plus 2.4. And this one is x minus 0.8. So we're almost there. We have it in factored form, but we don't know A, the dilation. That's where these get a little tricky. Has this been dilated at all? One way to check, and this is how we've done it in the past, is we've looked at the parabola and we see, as I move 1 to the right, is it moving 1 down? As I move 2 to the right, does it drop 4? When I go 3 to the right, does it drop 9? That's normal movement. By the way, we're talking about it moving to the right and dropping. What's normal on the parent function? Rising, moving to the right and rising. So before we even speak of a dilation, we definitely have a what? A negative, a reflection here. All right? So A is going to be negative. But let's find out if there's a dilation by picking any other point on the graph and plugging it in. Plug in 1.2 for x. Plug in negative 2.592 for y. Sorry, it's off the screen a little bit. There you go. Negative 2.592. If you didn't do this problem, if you got stuck and you gave up, you should be writing right now. We're plugging negative 2.592 in for y and 1.2 in for x in this equation. What's the only letter that we're not replacing? A. So guess what we're going to solve for? A. We're going to find the dilation. We're going to put 1.2 plus 2.4 times 1.2 minus 0.8. What is 1.2 plus 2.4, John? Good. Other John? 1.2 minus 0.8. 0.4. Sure. $1.20 minus 80 cents, 40 cents. There we go. 3.6 times 0.4. Help me out. 1.44? Good. Okay, so it's 1.44a, right? That turns out to 1.44 times a. Now what to find a? One step. Divide both sides by 1.44, and you should get a equals negative 1.8. What you got? A equals negative 1.8. Is a negative? What does that mean about our parabola? It's flipped upside down. Does it behave normally, or has it been dilated? It's been dilated because 1.8 is bigger than 1. So this parabola should be stretched taller and thinner than your average parabola. So now we know that the equation is negative 1.8 times x plus 2.4 times x minus 0.8. That's the equation in factored form.